Can planting trees help us reach our climate targets?
How do we harness the power of the immune system? What new information does the Atlantic Ocean hold?
We'll be exploring all this and more on this season's 10 Things to Know About. This week, we're asking how where you live might impact on your health and well-being. When choosing where to live, we often consider practical factors, like how close we are to family, schools, or shops. What we rarely take into account is the ground beneath our feet. We need healthy soil to grow our crops and graze our animals, but soil types can vary greatly depending on where we live. Geophysicist Jim Hodgson is leading a project to map Ireland's soil.
So we have different types of soil, and it really depends on the different types of rock we have below. So some areas we have very good soils for agriculture, like over limestone in the Midlands. In other areas we might have more peaty soils over different types of rocks, particularly in the west of Ireland.
I don't know if people kind of appreciated this, the rocks underneath that kind of determine the chemistry of the soil above them much, do they?
Probably not, no, but it's really important. The animals, the sheep, the cows eat the grass, and the chemistry of the grass is dependent on the chemistry of the soil below, which comes about from the rock types. So the rocks inform what the soil is, which informs what the grass and what the animals therefore are eating.
The TELUS mapping programme combines airborne and ground-based surveying to gather information on the geology of Ireland and examine the chemical elements contained in different soils across the country.
We started about 10 years ago in Donegal, and we're visiting about 20,000 sites. So we're going to end up with lots of bags of soil, and we analyse for about 50 different types of elements. And once we have all that information, we can make maps, and that will tell us about areas where we have very high levels of certain types of elements, and others areas where there's deficiencies or low levels.
And tell me about some of those elements that are kind of important, that we know that are important for crop or animal health.
So one area for animal health is cobalt deficiency. This can actually affect sheep. There may be muscle wastage, even their wool might be affected. And therefore, the farmers might need to add a supplement to the feed. And this particularly affects places like Donegal and Mayo, where they have very granitic type rocks, and therefore the soil itself has very low levels of cobalt.
How do you go about taking soil samples from 20,000 locations?
So we start off, we basically have a big grid across the whole country, and we go and visit each of these grids. We take what's called a composite sample. So we take 5 holes, and we take a bit of soil from each of these holes, and we fill a bag, and hopefully we end up with about 1 kilogram of soil.
The team want to assess the natural conditions of the soil, so locations are carefully selected to take samples far enough away from major roads and rivers to ensure the soil isn't affected by traffic pollution or water contaminants. They use satellite imagery to map out 2-kilometre grids and identify areas that can provide representative samples of the soil.
So we're going to head into the centre of this field here because it will be 100 metres away from the road and the road that we've just come in on back there. So it'll be around here.
So this is the centre point from where we take the satellite signal from, and around this we take 4 separate samples. So that's one sample, and then I'll take my... Oh,
there's a bit of rock there.
Now this can happen, so ideally we want to get the second sample at the red marker there, which is 50 centimetres, but there's a rock there. Now, if I was really strong, I'd push right through the rock. But we take the second sample from the deepest part we can get.
The samples taken from the field are analysed for soil health indicators, such as pH level and nutrient content. Rebecca Hall is interpreting the data to assess the health of soils across the country.
A healthy soil would absorb water through the rain, and it would provide an environment for crops to grow and also biodiversity. And without a healthy soil, your soil won't function. We won't have food, we won't have clean water, and we won't also have clean air.
And explain to me what happens if you have, say, a certain type of element in your field and how that might determine how you farm it against a different field.
So, for example, phosphorus. Phosphorus is an essential plant nutrient. You can't have crops without phosphorus. We need to apply chemical fertiliser to the soil to sustain that phosphorus. It doesn't act the same in every field. There'll be different chemical characteristics. And on the other side of that, if you have too much phosphorus in your field, that could run off and go into watercourses, and that'll cause toxic algal blooms and eutrophication. And it's one of the reasons why Ireland isn't meeting its water quality target.
So actually managing phosphorus is kind of critical for agriculture in Ireland.
Absolutely.
To date, the project has analysed and mapped 50% of the soil across the country, and the aim is to complete the work in the next 2 years.
If we don't have good quality soils, good healthy soils, obviously that's going to affect the crops. And there's new directives coming in from Europe now that we as a country need to understand our soil health and monitor them as we go along. And having that better understanding and understanding the science behind it, you can then kind of advise people a better way to manage their soils.
We know it rains in Ireland, but this summer saw the wettest July on record, 217% more rainfall than average. This may have put a dampener on your barbecue plans, but more seriously, it may have had a health impact for the hundreds of thousands of people who get their water from private wells.
In some counties, 90% of the water supply comes from groundwater, so where you live can have a massive impact on the quality of the water you drink. On a suitably wet day, I'm meeting Gino Dwyer, who is studying how the water we take from the ground affects our health.
People know what groundwater is, but it's really hard to conceptualise, even for somebody that works in it. It's the water way beneath our feet, but the water that's in the ground beneath us, it can come from rivers and things, but it mainly comes from rainfall infiltrating through the subsurface into aquifers in the ground. But if you think about rainfall or anything on the surface that can contaminate it, like manure or like a faulty kind of septic tank, the rainfall will pick up all that contamination and move it through the subsurface. So generally, the more rainfall, the more movement, the more likely you are to get contaminants reaching into the groundwater bodies.
Despite the importance of Ireland's natural groundwater resource, it's not regulated by the state and can often remain untreated.
So we go around and we try to assess the quality of groundwater and what people are drinking to see if they're potentially ingesting any contaminants that could make them sick.
And what are you seeing when you test that water?
The water quality is pretty poor. We get anywhere between 40 and 60% of the wells in the country, depending on where they are contaminated with E. coli. Most people have heard of E. coli. It's a fecal bacteria, so we find it in faeces.
40 to 60%, that's kind of amazing, isn't it?
Yeah, it's very high.
Jean has also been testing the water in private wells for a specific strain of E. coli called VTEC, a pathogenic bacteria that can cause severe illness. Ireland has the highest incident rate of VTEC in Europe.
It's particularly harmful for kids under 5, the immunocompromised and the elderly. It disproportionately affects Ireland, I suppose, because we're a bit unique in that we have such a reliance on agriculture. And then also, we have a very heterogeneous geology. And you know this if you've ever been to the Burren and then went to Wicklow. Joe, we're quite different in terms of the rocks beneath our feet. And this plays a big role in groundwater contamination. So Ireland kind of is the perfect storm mixed with the fabulous weather that we have here in this country. Joe, all of that is just the perfect recipe for the transmission of waterborne diseases.
For anyone concerned about the water quality from their private well, treatment systems can be installed to remove chemical contaminants, as well as harmful bacteria and microorganisms. Farmer Richard O'Byrne is one of the 750,000 people in Ireland who gets his water from a private well.
Tell me about your private well.
Well, the private well I have is 30 foot deep, and there's 20 foot of water nearly constant in it, so it's only 10 foot and you get the water. I guess we only got conscious of water quality over the last 15, 20 years. And so we started looking into our own water supply. It seemed nice to taste and everything, but then when we got it examined, there was contamination. So we looked into a new filtration system, and I put that in about 10 years ago.
So this is your water treatment system?
Yes, this is where it all happens. So we have the water coming from the pump here, up into our pump, and then we have one that goes to the house, which is controlled by this one, and this one is going to the farm.
Richard's water is passed through a series of tanks where ultraviolet light inactivates harmful bacteria like VTEC, and a series of filters removes any dirt and cloudiness from the water. Bacteria are invisible to the eye, so the only way to know they're present in water from private wells is to take samples. Researchers like Liam Burke are seeking to create models that will help predict when wells are most likely to be contaminated.
Part of the project, we've recruited a number of private well owners within the catchment, and the deal that we have with them is we'll test their water for fecal indicator organisms, same as the water test that you would get from a commercial lab. So here we're just going to test the water sample to see whether there's fecal indicator organisms in there. We just take 100 millilitres of the water sample, and we're just going to add in our ColiAlert reagent now. And this reagent is, if there's bacteria in the water sample, the reagent gets metabolized and it releases an indicator. And that indicator will show up yellow if there's coliforms in the water sample. And if there are E. coli in the water sample, it'll fluoresce, or it'll be fluorescent when we look at it under the UV light. The second technology that we're developing, which requires, I suppose, a lot more field studies, is a risk model. And so to develop this model, we're collecting a lot of data through field studies where we're testing private wells, rivers, and other water sources in a catchment area. And we're trying to map over the course of a full year how the levels of E. coli and virotoxigenic E. coli change in that catchment, and how this relates to changes in weather conditions, changes in rock, geology, soil type, population density, and the output would be a website essentially that people can use and plug in their location, and it can predict based on what time of year it is the risk that your well will be contaminated with VTEC.
You see, but you do not observe. So said Sherlock Holmes to Dr. Watson. Because where we live leaves a mark on us, and nature will give up her secrets to those of us who know where to look. In 1959, a man went missing during a trip down the Danube River. Another man with motive to kill him was suspected, but with no body, there was not enough evidence to build a case. During the course of the investigation, a pair of muddy boots belonging to the suspect were discovered. And stuck in the mud would be clues in what would become one of the first ever cases of forensic palynology, the study of pollen in crimes. Pollen is incredibly resistant to decomposition due to a cell wall made of tough cellulose and sporopollenin, a highly resistant organic molecule. This means that pollen can be used as evidence many years after a crime has occurred. And under the right conditions, it can even be preserved for millions of years. Examining the boots under a microscope, a pollen expert found pollen from modern spruce, alder, and willow, which were used to build up a picture of the murder spot. But crucially, 20-million-year-old fossilized hickory pollen grains were also found. These could only have been eroded from exposed rocks of Miocene age. When these clues were put together, there was only one small area near Vienna that fitted. And when interrogated with the evidence, the suspect confessed and led authorities to the victim's body in the exact area pinpointed by the expert. All crimes leave a trace, and pollen is both private eye and silent witness. See you next time.
After the long, cold, dark winter months, summer can't come fast enough. But for the fifth of the Irish population, that also comes with the fear of hay fever. Bernice O'Connor has suffered with hay fever for as long as she can remember.
I grew up in a really rural area, surrounded by farmland. So as a young child, straight from the get-go, I've always had symptoms. It feels like there's little grains of sand just under the eyelid, and every time you blink, it's just that kind of scratching. And I really just want to just pull at them. Then with my nose, it'll start off a bit of a sneezing fit. Then, typically the nose could just run a bit like a tap. But to be honest then, for me, what's quite frustrating is, let's say today I've got hay fever symptoms and my nose is just running. Then the next day I'll have aggravated sinuses. So it'll kind of continue on for maybe a day or two, even though there's no hay fever today, but my sinuses are now inflamed and aggravated as well. So
right.
Yeah, I get that extra little thing at the end.
So you lived on the Sligo-Mayo border growing up, and now you live in Dublin. Has that had a big effect on your symptoms?
Yeah, the symptoms in the rural setting were much, much more intensive. So I definitely struggled a lot more. And then when I moved to an urban environment, I was actually quite surprised that I would still even suffer with hay fever.
Hay fever is the most common allergic condition in Ireland, but David O'Connor is working on a project that aims to help people struggling with hay fever. David, why do people get hay fever?
Well, people breathe in things like pollen and fungal spores. There's actually a protein within these particles called allergen that causes all of these hay fever symptoms. Effectively, our body goes into overdrive, producing antibodies called IgE. These bind to mast cells, and when these mast cells with IgE on them come in contact with allergen, they produce things like histamine and other proteins that cause all those symptoms.
And is there a specific season for hay fever?
Yes, well, people generally think of the hay fever season in the summertime, and that's grass season. However, it can also start all the way back in January, all the way to August, September, October. That's the main peak of fungal spores. And actually, people don't realise that they can have an allergy to airborne fungal spores.
The pollen and fungal spores that trigger hay fever are produced by plants and fungus at different times of the year, and where you live can have a significant impact on how these allergies affect you. Rural areas often have higher concentrations of plants and fungus, resulting in more pollen and fungal spores. But that doesn't mean that people living in urban environments get it easy.
Pollen and fungal spores, when they're induced to stresses like air quality, for instance, they actually build up the amount of allergen they have within their particles. Then if you're breathing these particles in, you're dealing with more allergen, and you have all those symptoms that I talked about earlier.
Here in Ireland, do we get more hay fever than other countries?
No, we have generally the same amount of hay fever as other countries. What we do have in Ireland is a very large cohort of people who suffer from asthma, and actually hay fever can trigger those asthmatic symptoms. That can be very, very dangerous. We have the fourth highest asthma rate here in Ireland in the world. That's around 400,000 people that suffer from asthma. This is a trigger that really hasn't been looked at here in Ireland enough.
What are you working on to try and help people suffering with hay fever, David?
Well, one of the things here in Ireland that we don't really have is actually a pollen monitoring network. And if we don't have that information, if we don't have that high quality information about what pollen is being released and when, well, then we can't really predict when that pollen is going to be released. So what I want to do is to create an Irish pollen network to get really high quality data on the types of pollen that are being released and how much is being released into the atmosphere. And once we have that, I can be able to forecast what the concentrations will be into the future.
David is working with Met Éireann's Pádraig Flattery to develop Ireland's first pollen forecast network. They are doing pollen monitoring in the UK. Can we just use their data? I mean, is it that different?
Our forecast currently does come from the University of Worcester in the UK. And while it's adequate and it does give us an indication of the type of pollen, the amount of pollen in certain areas, it could be improved a lot more by establishing our own network, which gives us an exact idea of the pollen that's in certain places, and it also links in more with our weather patterns, because we can identify the weather or the types of pollen that are in the southwest of the country, and southwesterly winds then bring that towards the northeast of the country, and we can really assess the types of pollen that might affect different population centres.
So that accuracy really is key if you want to give people a good quality forecast for pollen.
Absolutely.
How do you measure pollen anyway?
In historical times and up until quite recently, it was done by manual measurements. So some sticky film is placed in an area, and then every week that film is analysed under a microscope to identify the types of pollen grains that are available. So we should improve on this significantly now with our new system of laser technology. Okay, so this is a high-tech laser which analyses the bioaerosols that are floating in the air. 40 litres of air every minute is sucked in through this tube up the top, and then inside this black box, a series of lasers act to take a 3D image of the bioaerosol. So any particle floating in the air is assessed by this machine.
Wow.
And we can then see the results live here as the pollen is coming through. So these little red dots show either fungal spores, pollen spores, even pollutants. We've trained the machine using machine learning algorithms. We feed in certain types of pollen and we know exactly what they look like. The machine can then figure out what that type of pollen is and get sent to a central database where we can really assess the pollen quantities and the pollen types that are in the area.
Very cool. How many of these stations are we likely to see across the country?
Ideally, we would have a network of maybe 10 stations. The urban centres, we would like to have them maybe around Cork, Galway, Dublin. And then for rural areas, we could locate them strategically so that we can assess the amount of fungal spores or the type of fungal spores that may affect plants.
The number of people affected by hay fever has trebled in the last 30 years. This increase is partly due to better diagnosis, but it's also likely to be climate-related, with warmer spring temperatures causing some plants to start producing pollen earlier and warmer autumns extending the growing season.
Some studies have already shown that hay fever sufferers will increase due to climate change. This also will happen because of a change of the type of plants that we can see here in Ireland. So currently in Europe, ragweed pollen is a big issue for hay fever sufferers. It typically grows a lot in Central Europe, but it's migrating north as our climate changes. So a study showed that the number of people suffering from ragweed pollen could increase by 50% by 2050. So that can really affect Ireland in future.
For sure it will be useful. Knowing that the data is relevant to where I am means that I can make maybe more proactive steps. So all of my kind of treatment at the moment would be reactive. I'd rarely sort of say, oh, you know what, it's going to be bad tomorrow, let me take some action. So I think that for me would be probably the biggest thing, is being able to sort of take some steps.
That's our 10 things to know about where you live. Next time, we check out the intriguing past and fantastic future of fungi.